So which of the following is a compound? You've got air, seawater, distilled water, or rock. So air, as we know, air can vary. So for instance, if I stood right next to a coal-fired power plant, there'd be lots of CO2 in the air. But the air would still be called air. So that's definitely a mixture. Seawater can vary in its salt concentration. For instance, in the Dead Sea, there's so much salt that you can actually, it almost looks like you could stand on it. It's much more dense than water, than normal salt water, but it's still called seawater. B is a mixture. Rock just could be anything. It could be a billion types of different rocks. So it's more likely to be just a mixture. So C, distilled water, is a compound. Water is a compound. So we know that. Which of the following is an element? So we know water vapor is definitely not an element. Ammonia is NH3, so that's definitely not an element. And we know carbon dioxide isn't an element. But oxygen gas, even though it exists as a molecule of two oxygen atoms combined together, it's still an element. Okay? Question 5. Splitting water into hydrogen and oxygen takes a lot of energy compared to separating sand from water. Why is this so? If we were to split water into hydrogen and oxygen, it takes a lot more energy than just separating sand from water. Well, the reason is water is a compound. Components of water are very strongly held together by the chemical bonds in the water molecule. So in the water molecule, the oxygen is bonded to the hydrogens by very strong chemical bonds. So that's why it takes a lot of energy to separate. So we need a lot of energy just to separate these bonds, okay? Now sand and water is a mixture, and because these substances don't form strong chemical bonds, they are very easy to separate. They're easy to separate because they don't form very strong bonds, so we can just filter them out. Okay. Question 6. Mixtures are said to have variable properties. Explain how this can occur. Because mixtures don't have a set composition, they can be changed, so their composition can be changed, so their properties can vary greatly. For example, a mixture of alcohol and water may not be flammable when there's more water than alcohol, but changing the proportions, it will become more flammable as the alcohol percentage increases. So if I took 50% water, 50% ethanol and tried to burn it, it might burn, but it probably won't. But if I took 99% ethanol and 1% water, that would probably light on fire. So you can see the properties are changing just by changing how much of each chemical I have. Similarly, if I had pure water, or maybe 1% salt, 99% water, it probably doesn't conduct electricity very well. Compared to 99%, or maybe compared to 75% salt, 25% water. That might conduct electricity far better. So, similar situation here. Two substances are found in different locations. They share the same properties and cannot be decomposed into other chemicals. What is the likely explanation for this? These two substances are likely to be the same element. Since an element cannot be broken down into simpler substances, and both substances exhibit the same properties, it's very likely that they are composed of the same atoms. Okay? So that concludes today's lesson on classifying matter. We looked at the main classifications of matter, and in particular we looked at elements, mixtures, compounds, and molecules. So hopefully you've learned something about classifying matter, and I look forward to seeing you at our next lesson.